Trigonometry can be used to find angles. The important thing to remember here is that when you're looking for an angle, you use the inverse function. So this goes back to, remember, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The difference here is that you're looking for an angle. That means you use the inverse function. The way it works is this little -1 means you're talking about the inverse function. And rather than plugging in an angle, you're plugging in a ratio. And we know what sine is. It's opposite over hypotenuse. And if I take the inverse sine of opposite over hypotenuse, I get the angle I'm looking for. Same thing for cosine. If I'm looking for an angle and I'm going to use cosine, I don't plug in an angle, I plug in a ratio. Cosine is adjacent over hypotenuse. And again, that will give me an angle if I use the inverse cosine of adjacent over hypotenuse. Tangent, the inverse tangent, and the ratio is opposite over adjacent. And that will give me an angle if I'm using the inverse function. So let's take an example from the picture here. Let's say I wanted to find angle A and I wanted to use sine. So normally, if I'm going to use sine, it'd be the sine of an angle. But because I'm looking for an angle, I use the inverse sine, and rather than putting an angle, I put in a ratio. And the sine is opposite over hypotenuse. So the ratio is opposite 3 over hypotenuse, which is 5. So typically on your calculators, you have to do the inverse function, which is usually like a second function. So the inverse sine of 3 divided by 5 is, I'll round it to the 10th, about 36.9 degrees. If I wanted to find angle B, I could use cosine. And again, I'm looking for an angle. That means I'm going to use the inverse. And in what I punch in then is a ratio, not an angle, but a ratio. And cosine is adjacent over hypotenuse. So if I look at angle B, the side next to adjacent is 3. So the inverse cosine of 3/5 will give me angle B. And the inverse cosine of 3/5 is to the 10th about 53.1 degrees. So I could use tangent to find angle A or B also. So this was the measure of angle A, and this was the measure of angle B. Let's say I want to find angle A again, but this time let's use tangent. So if I'm looking for angle A again and I want to use tangent, I'm looking for an angle, I use the inverse function. Tangent is opposite over adjacent, which is 3/4. And the inverse tangent of 3/4 is 36.9 again. And again, that is the measure of angle A. Now, one thing that confuses you when you talk about inverse functions, often you see the little -1 to show that, but sometimes you'll see arc sine. Well, the arc sine is the same thing as the inverse sine. Or you might see arc cosine. That's the same thing as the inverse cosine. And arc tangent is exactly the same thing as the inverse tangent. You'll see these interchangeably depending on where you're working. Here are 3 examples of finding angles using the inverse sine, cosine, and tangent. So in the first example, I'm going to find angle A, and I see that I have the opposite and the hypotenuse. Opposite and hypotenuse is sine. I'm looking for an angle. That means I'm going to use the inverse sine. And if you use normal sine, you put an angle in there. But because I'm looking for an angle, I put a ratio in there. And sine is opposite over hypotenuse. So the inverse sine of 3 divided by 7 is to the 10th 25.4 degrees. And the next example, I'm going to find angle B, but I have the opposite and I have the adjacent. Remember, the hypotenuse is never the adjacent. So in this case, opposite and adjacent is tangent. Opposite and adjacent, right there, tangent. I'm looking for an angle. I use the inverse function. Opposite over adjacent is 5 over 11. So the inverse tangent of 5 divided by 11 is 24.4 degrees. Last example, I'm going to find angle C, and the sides I have been given are the one next to the adjacent, and the hypotenuse is 15. Adjacent and hypotenuse, that's cosine. Looking for an angle, that means I use the inverse function, and I'm going to plug in a ratio. My ratio is adjacent over hypotenuse, and the inverse cosine of 12 divided by 15 to the nearest degree is 36.9 degrees.